In the previous video, we had examples where we were able to undistribute away the coefficient in front of the x squared. So then we were able to factor it just as a regular trinomial with x squared as the lead term. But now we are not so fortunate. As we can see quite clearly, not everything in the problem is divisible by 2. So we have no means of being able to undistribute the number in front, which means our factoring is much more complicated. Fortunately, we have something that we can refer to as the box technique that can help us to factor these types of problems. It's not the greatest tool, but it's not bad, and it certainly beats just a random guess and check trial and error approach. So we'll make use of it here. So for starters, I'm going to take the first term here and the last term, and I'm going to put them into the upper left and lower right corners of my box. So I'm going to have 2x squared here, and then I'm going to put the 21 in this lower box. If that 21 had been negative, I'd make it a negative 21 down there. So whatever the positive negative sign is carries with it. So now I have to figure out what's going to go into those other two boxes, and then I'm going to use that to help factor. And so to figure out what goes in the other two boxes, I'm going to multiply the a and c coefficients. So if we go back here and kind of clean up our diagram, remember that this is the a coefficient, this is the b, and this is the c. So I'm going to multiply a times c. So when I multiply those, 2 times 21 equals 42. So now I need to find two numbers that will multiply to make 42 and also add to make my b coefficient. And that b coefficient in this case is 13. Now for 42, we've got 1 times 42, we've got 2 times 21, we've got 3 times 14, we've got 6 times 7. And so out of that group, we can see hopefully that it's 6 and 7 that add up to make 13. So I'm going to use those two numbers here. And so those are the two numbers with an x attached to them that are going to go into these other two boxes. In which box I put which one doesn't matter. I can go ahead and put the 7x in the lower left and the 6x in the upper right, and it'll still work itself out. So now that we have filled in the 4 squares of the box, we have to figure out what the dimensions along the sides of the box are, because that's ultimately the two sets of parentheses that I'm going to break this problem into. We're kind of connecting this polynomial, this trinomial, with the area of a box. That's not the most essential piece of this, but it just gives you a little visual representation. So what I'm going to need to do is I'm going to need to figure out what multiplies to make 2x squared. So what's going to be that first piece that goes into each set of parentheses. Now, if there was no 2 in front, it would just be x and x. But instead, I'm going to go with 2x and x. 2x times x indeed equals 2x squared. So I'm looking for two things that multiply to make that 2x squared. Then I'm going to see, all right, this x here is kind of the dimension of this segment. So now I need to see what do I need to multiply x by to make 7x. And so hopefully we realize that that's going to be positive 7. And so that's what I need to put here. That's what this dimension of the box needs to be, so that when I multiply length times width, I'll get the area. Each of these red numbers on the inside is the area of these individual little boxes. And then along the side are the dimensions. So x times 7 gives me 7x, the area of this box here. X times 2x gives me 2x squared, which is the area that's filled into that box. And so then I'm going to do the same thing for the bottom row. So now this dimension right here is this 2x. And then I need to figure out what this dimension needs to be so that when I multiply 2x times that dimension, 2x times that side, I get the 3x that I have in the middle. Well, it's 2x times 3, so I'm going to put a 3 there. And then I'm going to do the same thing. It's kind of taken care of for me for this last 21. If I note here, this dimension here is 7. I've got this dimension here is going to be 3, and 7 times 3 indeed equals 21. And so now these sides of the box that I've listed in, 2x plus 7 and x plus 3, are the two sets of parentheses that are going to be my factors for this expression. So I'm going to have 2x plus 7 and then x plus 3. So once I've gotten to this point, now the problem is just like our other factoring problems, where I'm going to set each of the parentheses equal to 0, and then I'm going to solve each of these mini equations. Now, over here, I'm going to have a little bit more work than just subtracting 7, because I'm left with 2x equals negative 7, and so then I still need to divide both sides by 2. Now that doesn't go in evenly, so I'm going to have a fraction as part of my answer. So I've got negative 7 halves as one of my two answers. The second set of parentheses is a little bit more ordinary, so I'm going to subtract 3 from both sides, and so we've got x equals negative 3 is our second answer, and so I'll list that off here. So again, the box is just a tool to help us navigate our way to the two sets of parentheses that we ultimately need. There are definitely other approaches that we can take to factoring these problems. We can do it without any type of device like this, where we just start off with 2x and x as our two pieces in the parentheses, and then just work our way through there. But it is not so simple as just finding two numbers that multiply to make 21 and add to make 13. This 2 that's attached to the x squared plays a role in that, and so this box method is a way of accounting for that 2 and helping us get to the two sets of parentheses. But if you don't want to use the box and you have another method that you've picked up elsewhere, feel free to do that, but I'm going to continue with this box approach in the next two examples.